Next, you take one 10 kilo ohms resistor, bend it well and connect it in series with one leg of the LDR. You take your time to do this so it looks nice. So we are now done with inserting the component onto the breadboard. We now connect what we have on the breadboard to our Arduino Uno board. I took an orange male-female connector, inserted it in one of the remaining holes in the same line with the other leg of the 10 kilo ohms resistor. Then took a male short black wire, inserted it in line with the other leg of the resistor, and took the other end to the power rail where I inserted it into one of the blue holes designated for ground. Then inserted a red wire in the same line with the other end of the LDR. Now that we are done with the LDR side, I then inserted a grey wire in the same row with the other end of the 220 ohms resistor. I now look for a wire that will supply the ground from the Arduino board to the breadboard. So since I breached the rail, I only need to insert the wire to any of the hole of the blue marked rail. So I used a blue wire for this. So we have 4 wires going to the Arduino board. That's the main ground wire, the grey wire which will be connected to one digital pin, then a red wire from one end of the LDR which will be providing a 5V supply from the Arduino board. Then the last, our orange wire which will be connected to one analog pin because it will be providing the analog signal from the sensor to the board. Now let's take the Arduino Uno board and do our final connections. So this side is for analog input and this part is the power pins where you can get your ground, 5V and 3.3V from. Here is also our digital pins. We have 14 of them marked from 0 to 13. Of course, there is also ground here. So I took the blue wire and inserted it into the ground of the power pins of the board. I then connected the orange wire to the analog pin 0 marked as A0 and then the red wire to 5V pin of the power side of the board. Check the account to watch the next part of the video.